So hello once again, and thank you for the opportunity to present our work. My presentation today is a bit more focused on pipe fishes, which is just to change the argument because we spoke so much about the seahorses, and now I know that Nuno is my new best friend. So my today presentation, I will discuss about population dynamics and life history divergence in sympatric Syngnathids, which is a case study on multi-species assemblage in the lagoon of Mar Piccolo in Taranto. So broadly speaking, we try to improve our knowledge on the species coexistence in this site, and we try to investigate some demographic traits of these fishes in order to understand how do they do and how they can coexist together. So when we speak about coexistence, coastal lagoons are an excellent models to study this because they act as ecological mosaics. In these places, even at the small spatial scales, we can see gradients, different gradients, even strong gradients in some environmental parameters, such as abiotic factors, nutrient availability, habitat availability, but also complexity. And this heterogeneity, fine scale heterogeneity, I would say, can permit us to study very well, to understand how they coexist. Because these environmental parameters at a small spatial scale can impact population dynamics, but also can impact recruitment dynamics and can eventually lead to the divergence of some life history strategies. All these things together can lead eventually to the coexistence of the species. However, this is quite complicated to understand because we need a lot of data to do these things. So one of the data we need are the demographic data. And this kind of information are surprisingly rare for the fishes, especially for the marine fishes. And understanding the coexistence, understanding how do they adapt, how do they acclimate to the environment is important. And it is important especially because of the climate changes, which are changing our scene, are going to change this even more. And these changes are going to be even more visible in the coastal lagoons because these places are confined, these places are having a low water exchange with the environment, and they're also shallow depth. So among all of these things that I already told you, the Syngnathid's are an excellent sentinel organisms to study these kind of things. Because seahorses and pipe fishes are having, these things already. They have particular traits, characteristics of their life history, which permit us to study very well these kinds of mechanisms. Pipe fishes and seahorses are having high site fidelity. They are also having low brood. They are sedentary and they do not swim a lot. So they can permit us very well to study how the species that doesn't move a lot can coexist in the same environment. And this is especially true because they frequently share the same ecological context. Especially in the Mediterranean Sea, we saw that Syngnathid's are particularly frequent in the confined environments. And sometimes in these confined environments, they also share the same habitat, which means that in the same habitat, we can see multiple species. So when they do this, how they do this? Well, for sure, species need to make some adjustment. They need to do something so they can live all together. These adjustments can be physiological, can be behavioral, can be ecological. So having a lot of species, having a multiple species in the same habitat is a good opportunity to study how they reduce the overlapping among species. And this gives us a great opportunity to study the coexistence. So as Dino already told you, but also Michele, we have a huge population of Syngnathids, or we had a huge population of Syngnathids in Mar Piccolo of Taranto. Mar Piccolo of Taranto is a great example to study Syngnathids, because at this site we have a lot of habitats. As you can see in this photo, we have a lot of habitats which vary in complexity. There are a lot of habitats which are perfect for Syngnathid's, like seabeds or algal beds. So Mar Piccolo is acting like a fine-scale environmental mosaic. So what we have do in this study, we didn't looked at the occurrence. We tried to go beyond. So we studied how low-scale environmental heterogeneity can impact the growth and the development of the Syngnathid's at Mar Piccolo of Taranto, and which are the strategies of their life histories that have changed so they can live, they can reduce this overlap among species. So what we have done, we performed surveys on 1 year basis each month, and we studied both seahorses and pipefishes, but most of our study, at least for the divergence among species, was concentrated on pipefishes. So we studied pipefishes at 2 sites, and we used beach scene to do that, and we covered almost 1,000 square meter per each survey event. For the seahorses, we used RO view, and we used scuba diving also at 2 sites. For seahorses, we added an additional site with artificial substrate that Dino presented in his PowerPoint, because this is the site where a lot of seahorses can be found. For pipefishes, for all species, we collected normal morphometrical information, such as species, sex, length. But for pipefishes, we also made photos of their head. So we used these photos to extract then their measures, and we used them for our analysis. So what we have found at the end, so which is the assemblage, the sympatric assemblage of the Syngnathid's we found in the Mar Piccolo. First of all, we found 6 species which were very, very frequent, and 1 which was just occasional. This occasional was Syngnathus tenuirostris, while the frequent ones were 2 species of the seahorses and 4 species of pipefishes. For sure, the most abundant pipefish species was Syngnathus abaster. Regarding seahorses, both seahorse species were more or less equally abundant. This assemblage was observed during the whole year, and the numbers and abundance of these assemblages was more or less constant during the whole year. If we focus our analysis just on the pipefishes, we saw some differences in the demographic differences among pipefishes. So here we found that for Syngnathus abaster, this one? Yes. We found for Syngnathus abaster that there was a strong season-to-site interaction, which means that they were different. They have some different strategies according to the site and to the season. For instance, pipefish Syngnathus abaster was smaller at one site in the spring, but in the other seasons was bigger compared to the pipefishes of the other site. On the other hand, Syngnathus tifle had more or less parallel demographic status, because the length of the pipefishes was more or less standard among different sites. We also found some different growth trajectories of pipefishes, and as you can see in this graph, Syngnathus abaster was quite different from Syngnathus tifle. So when we observe this graph, for instance, can I just go here, because it is much more easier for me? But no, I cannot. Sorry. So So what we have observed here, for instance, the growth here in this graph was isometric, which means that pipe fishes grew and gain weight more or less in the same way. So in the winter it was like this, but then in the spring and the summer we observed a different growth trajectories, because here it was positive and here it was negative. Positive, it means that it gained a lot of weight, and here it just got a little bit longer. For Syngnathids tifle, on the other hand, the growth was more or less standard. It was negative all the time. This negative demographic growth, this negative growth, can be quite an indicator of a not so good population status, because it can mean that the food isn't enough at the sites investigated. Regarding seahorses were found in a lot of habitats. We found a lot of seahorses in both studies, both site studies. We found approximately 400 seahorses, and we saw that the density peaks were in summer. The biggest densities were observed in the summer, and this increase in density was observed for both seahorse species. This is one of my preferred images, because here you can see, the complexity of habitats in Mar Piccolo. This is the mussel farm and the seahorses that are swimming among these mussel pools, which are the great representatives of the habitats inside the Mar Piccolo. So Mar Piccolo is a great example, because there are several habitats in which these species can overlap, like, for instance, meadows of Cimodocia nodosa. These meadows of Cimodocia nodosa, which we used also for our analysis on pipe fishes, where we collected our pipe fishes, is a habitat where 4 species of pipe fishes can be found. Regarding seahorses, the habitat occupancy is a little bit different, because there are some habitats that are specific just for one of the species. But however, for both of the species, we have overlap in one of the habitats. For instance, in shallow depths where we have rhodolith beds in Mar Piccolo, we have Hippocampus gutulatus. If we go in the deeper water to the mud, we can see just Hippocampus. But in the middle, there are the zones where 2 species can coexist together. So what we saw from our study that pipe fishes, however, are adjusting something in their life history, in their demographic, because they have different growth trajectories, but also speeds. How do they do that? Which pipe fishes probably use to reduce the overlap that the species are having. So they have, in some way, different life history strategies that help them to coexist in the same time. Phanerogamous beds are for sure essential habitats, and it is the biodiversity of Mar Piccolo of Taranto that leads to this coexistence, that permit this coexistence, because species, just because of this great variability of habitats, can also have an opportunity to adjust something inside them so they can live together. So this environmental heterogeneity is a must. We need to work not just on the species, we also need to work to preserve this environmental heterogeneity, which is very, very important. It is important also not just for the species, not just for the habitats, but also for all coastal assemblages that can be found in Mar Piccolo, at least. So I finished here, so I think I have 1 more minute, so if you have some question. One question?
I'll try to make it out. So you said that you have the same ratio for the 2 seahorse species, same amount of seahorses.
Yes.
We have a totally different story in the Hippocampus lagoon. It used to be one for 10 seahorses of the other species, so a quite different ratio. What are your thoughts on that? It's because of the complexity or the type of habitats that are available that promotes that?
Yes, because we have a habitat that both seahorses naturally prefer, no? Because we have a lot of mud, which is preferred, and deeper water, which is preferred by Hippocampus. And if you go in the shallower waters, we have Rhodolids beds, which are excellent habitat for Gutulatus, because there is a lot of food, it's shallow water. So yes, I think that the reason for their, let's say, concurrent coexistence of both species in the same habitat, in the same place, is because of this great habitat complexity that we have at Mar Piccolo, and for sure artificial substrate enhance this coexistence, because they are an excellent place for hide, for mate, for eating. So yes.
Thank you.
Thank you very much.